everyone. It is wonderful. Thank you so much for joining us today here at Microsoft Ignite. So in this session, we are going to talk about the O1 model capabilities. My name is Jennifer Marsman. I'm a principal engineer in the Office of the CTO.
And I'm Marco Castellana. I'm VP Products of Azure AI.
And one of the things that both Marco and I love to do is explore new models, test the limits, and see what's possible. So in today's session, what we want to do is share with you some of the experiments we've done, what we've learned, and then hopefully have that guide you in when to use O1 as the right model for the tasks that you need to do. So let's jump right into it. With the O1 series of models, there are two different models currently out. The O1 Preview is a new class of model that has advanced reasoning capabilities. And then there's also an O1 Mini version. So that is a great one to use. It has the same reasoning capabilities, just a lot less world knowledge because it's a smaller model. So when you think about things like coding, for example, that can be a really good choice to utilize. Now, what can O1 do?
All right, so what is it that O1 can do that no previous large language model could do? Well, as some of you probably know, if you go to GPT-4o, even the latest, greatest GPT-4o, and you ask, how many R's are there in the word strawberry, it will tell you there are 2 instead of 3. There are 3 R's in strawberry, in the English word. Because GPT-4o, and large language models in general, they can't do math. They can't even count. So O1 is different. O1 actually is not just a model, it's kind of an Asian framework, but it has the ability to do math. It can, as you will see in a minute, it can find correlations between disparate data sets, and that allows it to do a much deeper analysis than any large language model could do before.
That's right. So if you have used the GPT class of models and this isn't your first rodeo, then let me give you a couple insights that'll help you get up to speed faster. So first of all, it is not a straight upgrade from GPT-4o over to O1. So there are some models, like for example, when GPT-4o came out, this one gave better results, like better quality results, and it was cheaper to run and cheaper overall. So it was like no brainer, definitely upgrade everything. That makes sense. But O1 is a model that you want to use for a specific class of problems. And so that's what we want to share with you today, is make sure you understand that specific class of problems of when it makes sense to use. Now, in the current O1 Preview status that is available, there's a couple limitations I wanted to let you know right now. There's not a system message as you may be used to. There's more things coming. No parameters, no function calling, and the modality is text in, text out. However, OpenAI has announced that most of these features are coming. There is function calling, structured outputs, JSON, other modalities on the way. Now, when you think about token limits, there's an amazing website out there, aka.ms/OAI/models, that gives you the breakdown on everything you need to know on every model. And in case you're wondering, it's 128K input for both of these models, the O1 Preview and the O1 Mini, and then slightly different outputs, but very high amounts of tokens available. Now, the O1 model does run a little slower. You are going to see more latency because it is doing this rich level of processing. And it is going to use more tokens as well because of how it's operating using something called chain of thought. And we'll get a little bit more into what that means a little bit later in this talk. So although it has a little more latency, it has absolutely shown in the evals. So we have seen that if you take a look at some of these evaluations, you guys, it's really impressive. Like, take a look at these data sets. We have biology, chemistry, physics, so a lot of hard sciences, and you see those numbers leaping way up just because of the way it works. Also, math competitions, coding competitions. So these kind of things, you can see these numbers, these side-by-side comparisons. It's also done very, very well in the safety leaderboards. So if you take a look at these safety metrics, you'll see that it is either the same or better on, I think, all of these. So very, very good work being, responsible AI built in from the core on this particular model. All right, so leaderboards are incredible, guys. Like, we all love leaderboards, it's so cool. But how does it do on real problems? Like, that's the exciting part to think about, is we're all trying to solve problems every day. How could we use this model?
Yeah, y'all are probably not doing biology with this stuff right
No,
now. So let's see what it really does
Okay.
for business.
So this is the first example that I had that just blew my mind and made me very excited about the capabilities of the O1 model. So bear with me, I need a little bit of setup, but one of the things that I have to do every summer is schedule summer camps for my kids. And in the area where I live, the summer camps are just insane. It's like a different summer camp every week, and then each summer camp runs, so it may not be offered the week of July 12th, but it is offered the week of July, whatever +7 is, July 19th, I guess that would be. So those kind of things where there's different things offered different weeks, and it also is split by grade levels. And my 3 kids, one of them is graduating elementary, one is graduating middle school, and one is graduating high school this year. So they are all in like different like sets of things. So when you think about just this problem, at its essence, this is an insane constraint satisfaction problem, right? I have to figure out how to do all of these things. And it's an exercise that takes me hours and usually days, usually hours spread out over days to get them all in the camps that will make them happy, all right? So taking a look at this, I threw this challenge at the O1 preview model. So I asked specifically for a weekly schedule, all 3 of the kids. I asked for some time off. I want family time off on a couple of weeks. Give me 2 weeks through the summer. My husband and I will take off then too, and we'll do the family vacation stuff. And then I gave information, data about each kid. So each kid, Tori's entering 12th grade. She likes baking and dance. Fiona likes these things, et cetera, et cetera. And then all of their grade levels. And then I'm open to other things, but try to optimize for the things that they love. And then I said your output should be a matrix of each week of the summer by each kid. Like, give me that, because that's like what I'm working towards. All right? And the other thing I want to explain is that our input here is this catalog, all right? So this is just one page of the catalog. And as you can see, there's a whole situation going on in there. There's a lot of stuff happening, right? There is embedded pictures, there's bold formatting, there's different colors, different font sizes. This model, as I said before, only supports text in and text out right now. It can't process images. So I did not upload these pages as an image, but rather I did like a straight control copy, like I copied and pasted and dumped that in here. So think about what we're losing, you guys. We're losing all of the bold, all of the formatting, all of the bigger text size to recognize that this is a title. Like, it was just like a straight text dump, which is pretty crazy. So just think about that. And I grabbed 12 pages of that nonsense and dumped it right into the end of the prompt. Right now, there's not support for the Assistance API in uploading files, but so at the current stage. All right, so a lot of stuff happening right there. And I also so I grabbed 12 pages and threw that in here. It actually took about a minute to run, which is, I think, relevant. If you're wondering how long it took, it was about a minute. And then one other trick I didn't mention in the prompt earlier is that I actually asked it to go for a week longer than what was available, than when the camps were available. So they actually stopped the week before, just to see what it would do. And the output was so impressive to me. And the reason it was so impressive to me is that I ran this multiple times, and the number of hallucinations were so low. I think I ran it the first thing. I think I've seen I think I've run this query, I don't remember how many times, at least 20 times. And I saw hallucinations maybe once, one specific class was placed wrong. So the number of things that were going wrong was so greatly reduced than anything I've seen. And when you think about all of those details it has to keep track of, each kid and their likes, each class and what grade levels and what particular weeks it's offered, that's a lot of information. So the fact that it was able to do that successfully was incredibly impressive to me. If you do also compare this to GPT-4o, I wanted to run there too and see what would happen. And in this case, it was not able to solve the problem. Like, I looked at the output and I started like fact checking against the brochure and seeing how it would compare. And I just found error after error after error. It was putting kids in classes that weren't offered that week. It was putting like kids in the wrong grade level thing. It was not able to solve a problem of this magnitude, and O1 is. And so that's why I think it's a great example of kind of the level of complexity that can be handled here. One other note here is that GPT-4o did take about 10 seconds, whereas O1 takes a minute. But for that problem, I spend hours and days like doing that work. 1 minute, I am fine with that. Like, so think about what are the other problems like that where it's taking me this long and I can get it to, even if it's not real time, that can be super impressive and make you get your work done a lot faster. All right, so the main thing I want you to take away from that particular example is that the strength of the O1 model is in keeping track of that nuance, right? That very, very nuanced data, a large quantity of details, and the O1 model is able to hang on to that. So Marco, what's an example you've seen that's cool?
All right, so let's check this out now. We're going to go live here with this. Oops, that's the wrong one. This one. There we go. All right, now I'm in the Azure AI Foundry. And you will find, by the way, that if you go to deploy these models, these do appear now right here as deployable models in the Azure AI Foundry. Now, the O1 preview model may have a wait list, so you might have to apply for a wait list, although we are draining that as quickly as we can. And if you're unable to deploy it, never fear. In a little while, I'm going to show you how you can try it anyway. So don't worry about that. But, all right, so here I am. I do have a deployment of the O1 preview model. And I was in New York a couple of months ago. I spent a whole week in New York, which was awesome because it has the best pizza in the world. That's right, Chicago people. Yes, sir. But anyway, I know, it's fighting words, right? Anyway, I was in New York and I was meeting with a bunch of folks from some banks. Now, there was the head of I met with the head of AI of a major bank. And he asked me, he said, hey, can this thing do sell-side research? So first, I had to go look up what sell-side research was because I am a tech person, not a banker, and I was not sure what he was talking about. But once I looked it up, I totally saw what it was. And you're going to see it in a minute, too. You'll totally know what it is. It's these like reports that they put together on stocks, like on publicly traded stocks. Okay, so when I first did this, I did this originally with Microsoft stock. And then I decided that was maybe a bad idea for a stage presentation like this. So here is what I gave it. And now, like Jennifer said, as it stands right now with O1 Preview, you got to use it kind of old school GPT-3 style and pile everything into the prompt because it doesn't have the ability to do file search and function calling and stuff yet. So I piled all this stuff into the prompt. And first, I have my company Contoso with its ticker symbol here and its current stock price, $23.43. And then I gave it the kinds of data sets that would, in fact, go into sell-side research. So an income statement. This is the stuff you would find on an SEC 10Q filing. So here's the income statement for the past 4 years. Here is the balance sheet for the past 4 years with cash and inventory, stuff like that. And then we have cash flow statement and the valuations, like enterprise value, PE ratios. These are all the kinds of things that you would get from these kinds of SEC filings. And at the top here, I gave it nothing more than this. Create a sell-side research report for this company. That's it. That's all the instructions I gave it and that data. And with that, man alive, it totally did it. So here we have the top of the thing. It's making a buy recommendation with a 12-month target price of $30. It makes a little executive summary over here. We are initiating coverage on Contoso with a buy rating. All right. So then it has this investment thesis. And where it really gets interesting is stuff like this. With a compound annual growth rate of approximately 28.2%. Now, I run this thing all the time, and it does this every time. That number, 28.2%, is not in the data set that I fed it. Now, it is calculable from that data set. So it's calculating this number over here. It's not making it up. It's in there, but it was not specifically listed. So this is one example of it doing math. And if we actually scroll down here, we'll see more examples of that. So we'll go past the industry overview. So this is the financial analysis that it does to arrive at its buy rating. And here we see the percentage increase year over year for the past few years, which it also calculated from that income statement. You can see that it maintained about a 40% gross margin, 20% operating margin. Again, all of these things have been calculated, and it notes the improvement between 2020 and 2023. It likes the balance sheet here, it likes the cash flow here, and so using the current ratios, it's like, you know what? This is how it arrives at its target price. So it actually calculates the target price of $35.70, but then it's like, but to remain conservative, let's make it $30. That's fair. Actually, that makes sense, right? And so as a result, that's its conclusion. Contoso presents a compelling investment opportunity. So the answer is yes. You can use this to do sell-side research that is backed by this deep analysis. And like I said, this doesn't just do math, it finds correlation between disparate data sets. I gave it 4 different data sets here that are related only by the fact that, well, it's the same company and it's the same time frame. And it's able to find these kinds of correlations to form this conclusion. Now, as Jennifer mentioned, one of the other things that O1 is good at is coding. So let's check this out. Now, I did this in advance just a little bit earlier here. So here's what I told GPT-4o to do. So I want a self-contained HTML page because it makes it easier to do this kind of demo. I want an HTML page with some JavaScript on it that has a Space Invaders game. So I said, GPT-4o, do that. So it gave me this nice self-contained page. Thank you, GPT-4o. I'm going to copy that into my little text thing here. So, okay, my invaders.html, and let's reload this page that I just pasted it in. I mean, not so good. My triangle doesn't even move. I can't shoot, and my invaders have gone off the screen. So, not great, not great. GPT-4o, it would probably need a few iterations to get that right. Now, I also ran this exact same prompt with O1. So here's the same prompt, O1 preview this time. Now, to be fair, GPT-4o spits this right out. I actually could have done that one live and you would have seen it. It takes, like she said, about 10 seconds, right? This O1 preview, I ran this. I think it took about 2, maybe 3 minutes. So, you know, probably not wise to do that live on stage here. It gives me some instructions. Let's take a look at what this code does. So let me paste this over the code that I had here and save it. And I'm going to reload this page. Let's see what we get from O1. Oh, boom, now we're talking. Now that's some Space Invaders right there. That's the real deal. So O1, well, it took a lot longer, but it did it right on the first try. And with that, Jennifer, back to you.
Awesome. Thank you, Marco. All right, so you've seen some really amazing examples of how this model is able to do things that it wasn't able to do before. And so you may be wondering how, what is it doing? How is it able to do these kinds of things? And so OpenAI has stated publicly that it is using a technique called chain of thought. So what I want to do is show a very quick explainer. This is a demo video that I created literally a year and a half ago, I think, to show people what kind of chain of thought is, if you're not familiar. So and this is just a basic technique that we use in prompting to help guide the model a little bit better. So the example I want to show, if you take a look at this little video, what I have here, so first of all, this has nothing to do with O1, right? This is an example using a different model. And I'm also using a very, very old model because a lot of these newer models will just get it right out of the box, okay? So that's why I'm doing that. Old UI, old other things. So don't focus on that. The point of this is, what is chain of thought? So I'm going to give you an example where I'm asking the model to solve a math story problem. So it's about Janet's ducks. They lay 16 eggs per day. She eats 3 for breakfast and then makes muffins with 4. So she's gotten rid of 7. That means there's 9 left. And then she sells that remainder for $2 per egg. So the right answer is 18, right? We all just kind of Did that math and agree that it's 18? So I've run this a million times, and usually in this model, this older model that I'm using, it could almost never get it right out of the box. Occasionally it would luck out and get it, but almost consistently I would confidently show this in front of customers all the time, and it almost always failed. However, if we add this chain of thought, so look at what I'm doing. In this case, I'm using few shot examples, and if you see what I'm doing here, instead of just giving an answer, I'm talking through the answer to help the model figure out how to reason. So a very simple example, like if there's 3 cars in the parking lot and 2 more arrive, instead of just answering 5, which we all know, we say, well, there's 3 there already, then 2 more come, and 3 plus 2 is 5, so the answer is 5. And remember that all these models are doing at the end of the day is generating text. So when you can guide them to generate kind of the steps and talk their way through the process, they are far more likely to kind of land in the right place and get better answers. So that's just the technique called chain of thought prompting. And you see here that once I did that, and I have another couple of math problems where I work through them step by step like that, and that enabled the model to, again, consistently, I've run this many, many times, consistently, it will come back with the right answer then.
I mean, it's interesting because like last night, I was helping my daughter with her math homework, right? She's doing some trigonometry. She's a freshman in high school. And we basically did chain of thought reasoning, you know? I mean, she had these problems that were really complicated.
Yeah.
It was like interlaced triangles and stuff like that. And I kind of walked her through it in a chain of thought way. I'm like, you solve the bigger triangle, then solve the next triangle, then solve the next triangle, until you get to the answer, you know?
How we
so
learn.
it is chain of thought.
It's
not that different from how we think.
All right. So let me share with you a few more examples of things that I have tried and tested and kind of what the results were. So I wanted to test something with a large code base change. So I used the prompt right there, using the provided documentation below, give me key changes between 2 different versions of an API. Then craft a blog post for an audience of developers. And then what I did at the bottom of that prompt was I stuck in one of my favorite APIs, which is the Azure Content Safety API. You should all definitely go and learn about it later. And I grabbed a version from when build last year, so early 2023. And then I grabbed another version from earlier in 2024. And I just did straight copy paste from the web page docs and dumped it into my prompt and ran that. And you guys, it found all of the differences that I found, plus some other ones. I'll show you in a second. Then I have another one around agentic workflows. So in this particular scenario, what I wanted to do is see, okay, if they did have function calling, how well would it be able to do with that? So what I did is define in the prompt a few little functions. And so I used a Minecraft example here. My kids and I love Minecraft. And I asked it to build a diamond sword. And there's some Minecraft math involved. You guys who play Minecraft know that 1 log equals 4 planks, et cetera, et cetera. So I did the Minecraft math and tested it, and it actually did an amazing job coming up with the right things using those functions I defined, wander around in the world, craft something, punch, punch a tree together, wood, those kind of things. So I defined a whole set of those, and it did a great job. The one thing it did forget, the math was perfect of the exact number of logs I needed to get, those kind of things. There was a note at the bottom though, in the step-by-step, it gave me detailed numbered examples as an output. But then in the example that or at the very bottom, it had a little note saying, you might need additional wood or coal for fuel, because it actually didn't account for needing some extra wood. There was extra wood needed to be able to smelt things. So it was almost perfect other than that, and it did actually have a note at the bottom. It just wasn't included in the steps to grab that extra stuff. And then finally, a productivity example. I looked at the University of Michigan football schedule, go Blue, and I wanted to compare it to my weekends. So what I did is I took, again, from the website, I found this, there was something to download as, I think, a CSV. And so I took that and I dumped that in my prompt. Here's the schedule. And then I took my calendar in ICS format, which is a text-based format, actually. Did you know that? I always assumed it was binary for some reason, which maybe is silly. But you can go into your Outlook calendar, right-click, hit export as ICS. I exported that all out. I stuck that in my, and I just dumped the contents of that file in the prompt. And I exported with the title of the thing only, so only the titles of my meetings. And I put it in my, and in addition to that, I did my, I put it in there and put it all in there, and I had exported it only for the college football season. So I think it was pretty large. It was from September to like mid-December or whatever the college football season is. So I put that all in there. So again, ton of things, and it went very well. So let me just jump over here real quick.
Now she's using Azure AI right here to log into her computer.
Thank you. There you go. All right. So, so let me just show you really quickly some of the things. I wish I could like sit and walk you through every detail of all three of those scenarios, because it's really the little nuanced details where you're like, oh, it caught that, oh, it caught that. So I'm gonna try to give you one simple example, and then I put all of this in a GitHub repo for you, so you can go rerun my experiments, try these things out for yourself, and see exactly what I saw and get excited about these scenarios. So here is an example. So this is the content safety one. So here's what the request body looks like here. So you can see that they did actually change between, this is the 2023 version, this is the 2024 version. By the way, you guys, I strategically chose 2024, because you might say, yeah, Jen, like that's really impressive. It came up with a blog post, but couldn't it have pulled that from its training data or something? And the answer is no, my friend, it could not, because the training data cutoff was actually October 2023. And so I purposefully chose a 2024 version of the API in order to make sure that, that we would be able to not have any training data corruption. All right, so you see here, like one of the things, break by block list is halt on block list, and some of these other things. There's changes in the numbers of tokens it can handle. There's a whole bunch of nuanced things. And then if you jump over to here, you can see that it actually caught a lot of these, all of the changes I found, plus some ones that I hadn't seen, some really minor ones. And so it grabbed the increased text limit, it grabbed the new level of severity that it changed from different scales here. It grabbed that break by block list versus halt on block list. So a lot of really cool insights here. So again, like it's so much fun to go into all the details, but we don't have time right now. So what I did is I did throw this all in a GitHub repo for you. So this particular notebook that I was just showing here, it contains all of those examples that I just was showing. And they're all here for you to run and try yourself. So feel free to go here and check it out.
Scroll that to the top so people can take a picture if they want to take a picture. This is
there you go.
The O1 Analysis Notebook under Jennifer Marsman, her full name.
Jennifer Marsman, O1 Analysis.
All right.
Okay, so now let's jump back to main here.
You're there.
All right, and then, all right, so you already saw that. There is a link to the repo. Feel free to check it out and peruse it at your leisure. And really cool examples that have worked really well. Now, there's other things that work well, like all the media saying math, puzzles, coding, those are the things. But I just want to argue the opposite side for one quick second. When you don't need it to keep track of this large, nuanced amount of data and make sure it's, keeping track of all of these little details, like GPT-4o is still an amazing model. So, and in a lot of times, it can get the right answer and it can get there faster than the O1 model. So if your problem is not of the complexity that it needs or warrants the O1 model, like use GPT-4o. It'll be cheaper for you, it'll be faster for you. There's a lot of goodness there. So like one example I wanted to share, there's another math problem. This is probably like upper elementary level type problem. And this one, both GPT-4o and the O1 preview can get this math problem correct. All right? And GPT-4o does it a lot faster and a lot cheaper. So I just want you to keep that in your heads. You don't need to move everything there. So really try your scenarios, try them side by side, and then see how it works. But if only we had a good way to try these models side by side, Marco.
If only, if only. Now, earlier, when I was showing you the deployment thing, I did promise you all that I would show you a way that you could try this stuff yourself, even without deploying this in Azure. And that time has come. This is the GitHub Model Marketplace. Well, actually, it's just the GitHub Marketplace, I guess is the way to put it. And here, you can actually try a whole bunch of different models. So here we have, GPT-4o Mini and stuff like that. Now, I am going to click into the models, over here. And in this tab, if it loads, come on, then we should indeed find the O1 models are available. And here they are, OpenAI O1 Preview and O1 Mini. Now, when you click into this, here is the trick. You can actually put a message right there, or you can click into the playground. And when you do, you can actually put a prompt right in here. But I'm not even going to do that, because a little known fact is that there is also this compare button right here. And so, as Jennifer was just saying, you should do a comparison to figure out which one is going to be best for you. So let's try this. So I'm going to press this button, and that gives me 2 playgrounds. Now I am going to compare O1 Preview, and let's go ahead and compare it to, where's GPT-4o? There it is. And the way that this works is that when you type in one, it types in both. So I'm going to paste this data set right on in there. And I'll show you what this data set is in a second, because GPT-4o is going to get cracking over here, but O1 is going to take a minute. So there goes GPT-4o. Now, I'm going to show you, what is this data set? Well, I was meeting just recently with a retail customer. It's a major retailer. I'm sure you know them. And they showed me some of their data from a single store. Now, this, of course, is not exactly that data, but it's patterned directly after it. And so we have our single store sales data for the month of August 2024. And we also have, again, a disparate data set for that store. On the right-hand side, we have the staffing data for that same month. So these are the people, not real people's names, of course, that were working shifts at that store. And so the task is for our O1 model, or GPT-4o, to find correlations in this data set. Now, let's take a look at what GPT-4o gave us. And like I said, I piled all this data directly into the prompt. Now, it actually does, even GPT-4o finds some interesting stuff, like the fact that significant sales peaks occur on weekends. But of course, that's only going to be in the same store sales data. So it's not really finding any correlations here. I mean, it says it's finding correlations, but everything is in that one table over here. Discounts, footfall, which is a term for people walking in the store, abandon rates, that's all in that one table. So, you know, it kind of suggests some things that are vague, like enhance the weekend experience. Okay. But, you know, it's not that data-driven, really. Now, if we look over here at what O1 did, on the other hand, okay, now we're talking, right? Now O1's doing the math. So it's not just saying this in generalities. It's like, it's specifically like, okay, 2,000 customers on August 3rd compared to 450 on August 1st. And it's calculating things like, it'll calculate totals, it'll calculate averages, it'll calculate percentages, like it does over here in the purchase rate. Average transaction value, which it also is calculating from this data set. And let's see, if we dig down here, now I just ran this, and usually what it does, there we go. So it does find the correlation between, now it is true that for this store, and this actually was true for this retailer as well, that their staffing on weekends was exactly the same on weekdays. They had the same number of people working at the store on weekends as they did on weekdays, but they had more than double the number of people walking into the store, like customers walking into the store on weekends. And so the staffing did not match the customer count. And that actually did, in the data set, increase their abandon rate, people walking out without buying anything. So O1 finds this quite reliably, where it finds the correlations between these two disparate data sets and is able to be like, okay, you need to increase your weekend staffing, and here is why, because staffing hours are similar on weekdays and weekends, despite higher weekend traffic, which the traffic is in the other table. So when we talk about finding correlations between data sets, that's what we mean. And this does point to, by the way, a trend that's now happening in generative AI. You know, up to this point, large language models, generative AI has been for language, and that's it. That's what it, so you know, you do your summarization and you do your content writing and stuff like that. But now you're starting to see this convergence between some tasks that you might consider to be traditional machine learning, things like finding correlations. Now, I still wouldn't build a propensity model or a churn model with O1. I would not expect it to be able to do something like that. But for analyses like this, that's what you can do. But getting back to where I was, now in here, you can compare O1 Preview to GPT-4o, or you can compare it to, say, O1 Mini. I can give the same prompt to O1 Mini. We'll see how much faster it actually is. So O1 Mini, unlike GPT-4o, it doesn't spit it right out, right? Still, O1 Mini is thinking about it. It's still doing that chain of thought reasoning. It's just a little bit more mini. But it is able still to find a number of these same insights. It's still able to do this kind of math. So maybe not as good, maybe not as deep as what we see with O1 Preview, but still pretty solid and still worth a look. But my meta point is that here in the GitHub Model Marketplace, you can try this right now. You don't have to deploy anything. You can try this. You can try all these other models, not even just these O1 models, GPT-4o. You can try the new Mistral small language model, which just showed up in here. The Llama models are in here. Phi 3.5 Vision is in here, so you can try some of the multimodal models. But this is a quick and easy way to smoke test a whole bunch of these different models. Back to you.
Right. All right. Thanks, Marco. All right, so hopefully with the scenarios you've seen today, you understand what the O1 model is really good at. When you think about, all of the details of scheduling those summer camps and all of the noise in that data, like the amount of, the signal to noise ratio was so high. So, and when you think about the financial scenario, the scheduling with a whole calendar of months long of data, so many examples where the real key kind of common thread I'm seeing through all of these is that it's a situation where you have large quantities of very nuanced data, and you need to understand the nuance and the detail in that data. So that's where I think these models really shine. And because of that tendency, that's why they're good at math and at coding and some of these things that we're seeing. So that is really the value add of the O1 model. I want to reiterate the point again. It's use the right tool for the right job. You don't want to jump in and move everything over to O1. But it's just a different class of reasoning model than the GPT-4 series. So hopefully after today, you understand its strengths and where to apply it best. And then finally, you can try this now. You saw some of the cool stuff that we were doing, and you can request access and deploy it in the model catalog at ai.azure.com/explore/models. And there's short links for the ones there, as well as.
Or try it at the GitHub Model Marketplace. And you saw the URL, or you could just type that into your favorite search engine. It'll take you right there.
All right, and we can't wait to see what you guys build with it. Thank you.
Thank you all. So you want to take questions?
Yeah, I think we have time
all right.
for a few
questions. We do have a
questions.
couple minutes, so if you folks now, hopefully we have injected into your chain of thought. I should try this model.
There's a mic right there, so if you guys want to queue up for the mic so that the people online
right there.
can handle the questions. Thank you. I saw he had a question, so feel free to line up at the mic.
Anybody has a question, feel free
we get it on
to
audio.
step up
Thank you.
to the mic, which this gentleman has just done.
Sure. I hope you can hear me. One question, you mentioned the file and image situation that the O1 Preview doesn't work with them right now. Do you have any timeline or any further information when the new O1 models can support them?
Unfortunately, we cannot share a timeline on that right now. So that is, it's up to OpenAI to kind of release that stuff, and once they do, then we can do it. But that's not something we can share just here.
And one more follow-up question. Is there a way to measure hallucination of the models?
Yeah, so have you seen the Azure AI, the evaluation work that's done?
Yeah.
Okay, so some things like that you can use. They have some metrics in there to help with some of these things. Like there's a groundedness metric that can be really helpful to see how well it's grounded in the data that you bring. So you can do things like, here is my source of truth, and then measure the groundedness very easily to see how well it does against that source of truth. Oh. So those kind of things can be really techniques. Definitely check out some of the eval sessions when they go into those details, because they're building some really cool stuff on that team.
Yeah, and so if you find that there's a speaker by the name of Mernoush Sameki, anything that Mernoush Sameki says will answer your question directly.
Yeah.
Okay, thank you.
You're welcome. Hello.
Hello. Can you imagine integrating O1 into the Ignite web page next year to plan our session schedule?
I know, right? I almost built that demo. That's so funny that you say that, because that was one of my ideas of to build, and I ran out of time, but completely. And same thing, there's so many cool sessions, because I was thinking, okay, you could put in like, here's my preferences, like here's what I love, here's what I need to learn for work, here's like the find me and here's the speakers because I plan based on speakers too. Like if there's some people, like I don't care what you're talking about, you're a really good speaker, so I'm gonna come see you. So being able to throw all of those like constraints at the model in a similar way and have it like come up with your, it would be amazing. I love it.
Yeah, it's basically just a joke, but it would be.
Yeah.
I know.
It's a good idea.
Not a joke to me, man.
actually.
Like I started building that and I ran out of time.
And once we have function calling, it can actually call your calendar directly. It'll be like, put it right in there.
Put it right in.
Just like I did in my agent session yesterday, by the way, which you totally can do with assistants today.
Thank you.
Yeah.
All right. Any other questions? Anybody else want to step up to the mic? Oh, well,
Got
we
one
do
right
have
there.
one. Please feel free to make your way over.
Couple.
I think-
Yeah, both of you. Feel free. Yes.
yeah, go ahead. We got like 5 minutes. We probably can take 2.
Regarding the marketplace try feature, can we try them, or we have to register to try the O1?
No, you don't have to register on the GitHub Model Marketplace. That is public. You can try it. There generally is a token limit, so you cannot necessarily give it everything in there. And there's probably going to be, you're going to get throttled in there. Like, you're not going to be able to use it in production, so we have certain safeguards there. But
You
it's
can add
great
a
for smoke
product
testing.
key, I believe.
If it's
So
not available, the testing button over there, we need to refresh that or something like that. 'cause
Sorry,
it's
say again?
right. It's not available, the test in the GitHub.
It's not available?
No.
That's interesting. Maybe we can take it
why
offline.
don't you come grab us afterwards and we'll see if it's a
Yeah.
problem with
Yeah.
finding it, because the compare button, just make sure we.
I think you do have to be logged into GitHub to see it, though.
Yeah.
That is one thing. So if you're not logged in, then maybe it doesn't show as a playground.
But we're happy to help find
Yeah.
it. Yes. Hello.
Yes.
Hi. How many disparate data sets can be thrown at the model?
So it's only limited by the prompt input size. Like as we said right now, there's not been released yet the ability to upload files and stuff like you see with the Assistant API and such. So right now it's just, a lot of those Jupyter Notebooks, I'm just throwing massive quantities of text. So the text limit there is 180K input tokens, which you can do a lot of damage with that.
128K, right?
Oh, 128K, I'm sorry, yes.
Yeah.
I
so that
literally started thinking.
I mean, I have actually maxed out that limit. So I have given it a data set that does max it out to within 1,000 tokens. And that was a full-on spreadsheet, basically. I took a spreadsheet with multiple sheets and stuff like that, and I transcribed it into CSV, and I piled it all in there, and it does work. It does work. But, ultimately, I think going forward, you would probably actually pair this to a database and let it go query for data and stuff like that. Now, that's not possible right now because there is no function calling yet, but hopefully in the future you will have that ability.
Okay, thanks.
Thank
You're
you.
welcome.
All right, last question.
How long can I keep you?
You got 2 minutes.
Thank you for the presentation. Huge fan. Been doing a ton of testing, my team and I, on O1.
Great.
The other theme of this conference right now is agents and multi-agent frameworks. So
Yeah.
any thoughts on tossing O1 into a multi-agent framework, and is there any?
Yep. So
Oh, yeah.
Totally possible.
Yeah.
So we've done some explorations with that as well, and you can certainly add it in. There is, I think if you look at the Magentic 1 stuff that came out, which is based on AutoGen, that one, they had some of early, in the research report they released, they showed it O1 playing the role of some of the agents, and they had GPT-4o is the other agents and such, and so they were able to collaborate well. So it is a great thing there. And then of course semantic kernel, and
Right.
there's nothing limiting what model you use, so the models are fairly interchangeable
Yeah,
in a lot of
so
these multi-agent frameworks.
You could totally do that. If you had gone to my BRK 102 session on Tuesday, where me and Mads Bolaris did the agent stuff, I have my little questionnaire multi-agent thing, for which I'm using GPT-4o, but I've been thinking about changing out the question answerer to use O1 for exactly the reason that it will produce better answers, and because it's much more likely to respect my character limit parameter, because O1 can count,
Right.
And GPT-4o will totally blow past it. I'll be like, hey, you got 500 characters, stay in there. And GPT-4o will just talk and talk and talk sometimes.
I was at that session, and then the one main difference between 4.0 and 0.1 is that you can see the chain of thought that 4.0 is producing as you're trying to go through it, but with 0.1, that's kind of hidden from us in the reasoning tokens. So
For now.
So GPT-4o does not use chain of thought, like
So,
to be
Yeah.
clear, like under the covers.
Right.
in the
Unless
same
you
way.
make it
Yeah.
use the
unless you
chain.
make it so that
Right.
you
Right,
can see
with
the-
prompting level, just to be
Right, which is
super
what you-
pedantic about it.
Yes. All right. Well, now the question is, do we have any more time for questions? And the answer is no. So thank you all very much, and have a great remainder of Ignite.
Thank you.